temperature, that here we have represented as del T. Here comes the heat capacity or thermal capacity. It is defined as the amount of heat required to raise the temperature of a body through 1 degree. So, heat capacity is equal to mass into specific heat, that is m into C. In CGS unit of heat capacity, it is calorie degree Celsius inverse, and SI unit it is Joule K Kelvin inverse. Now here comes the factors on which the conduction of heat depends. So when two opposite faces of a slab, each of area of cross section A and separated by a distance x are maintained at the temperature T1 and T2. So here we can say that T1 is greater than T2. Then the amount of heat that flows in a particular time T is Q is equal to K into A and T1 minus T2 into T divided by X, the distance. Here K is the coefficient of thermal conductivity of a material of the slab between its two faces. Now the rate of flow of heat through the slab will be dQ by dt is equal to minus of Ka dt by dx. Here dt by dx is the rate of fall of temperature with distance and is called temperature gradient. Due to the distances, the temperature will be fall. So the falling of temperature with the distance x is the temperature gradient. Now here comes the coefficient of thermal conductivity. So it may be defined as the quantity of the heat energy that flows in unit time between the opposite faces of a cube of unit side. The faces being kept at 1 degree difference of a temperature. Then the CGS unit of a coefficient of thermal conductivity is calorie S inverse, centimeter inverse, degree Celsius inverse. Likewise for in SI unit it is Joule S inverse, M meter inverse and Kelvin inverse, or we can write it as W M inverse K inverse also. Now in dimensional formula, the coefficient of thermal conductivity K is M L T minus 3 K minus 1. Now the thermal conductivities of a metals are much greater than those for the another metals. So gases are poor thermal conductors. So here comes the heat, current and resistance. So the flow of heat per unit time in conduction is called heat current. So what is heat current? Flow of heat per unit time in conduction. And the ratio of the temperature difference between the ends of the conductor to the heat current through it is called thermal resistance. So thermal resistance is nothing but the temperature difference between the ends of the conductor. Now how we can represent the values? That is heat current H is equal to Q by T, which is equal to Ka into del T by del X. What is thermal resistance? How we can represent? It is RH is equal to del T divided by H, which is equal to del X divided by Ka. The SI unit of the RH, that is the thermal resistance, is Kw inverse. Then the dimension of the thermal resistance RH is M minus 1, L minus 2, T minus 3 into K. So here we are going to see some mode of transfers of heat. First one is the convection mode. So it is the process by which heat is transmitted through a substance from one point to another point due to the bodily motion of the heated particles of the substance. So you can see it in the image. The fluids are mainly heated through convection, and the natural convection arises due to the unequal heating and gravity when more heated and less dense parts rises and are replaced by the cooler parts of the fluid. And in forced convection, a material is forced to move by an agency like a pump or a blower. So this is about the convection. Now the another mode of transfer of heat is the radiation. So it is the process by which heat is transmitted from one place to another without heating the intervening medium. So, in between the medium and the heated object, there won't be any heating in between the intervening medium. So, this is the radiation. And what is thermal radiation then? So, the electromagnetic radiation will emit by a body by virtue of its temperature. It is nothing but the thermal radiation, otherwise it is a radiant energy. Now, the thermal radiations are electromagnetic waves of long wavelength and it will be ranging from 1 micrometer to 100 micrometer. Now, what is black body? Have you heard this word black body? Yes, it is a one which neither reflects nor transmits but absorbs whole of the heat radiation incident on it. So, the absorptive power of the black body is unity. Therefore, this black body will neither reflect or not transmits the heat, but it will absorbs the heat radiations incidence on it. So, here comes Stephen Boltzmann's law. So, this law states that the total amount of energy radiated per second per unit area of a perfect black body is directly proportional to the fourth power of the absolute temperature of the body. That is, we can represent it as E is proportional to T power 4. It is fourth power of the absolute temperature. Otherwise, we can write E is equal to sigma T power 4, where sigma is the Stephen's constant. Now, the values are, that is sigma is equal to 5.67 into 10 power minus 5 urge second inverse centimeter minus 3 K minus 4 is in the, this value is in the form of CGS system. Now, in SI system, sigma is equal to 5.67 into 10 power minus 8 W meter minus 2 Kelvin minus 4. So, if a perfect black body at a temperature T is placed in an enclosure of a temperature T naught, then the net amount of energy radiated per second per unit area by the black body will be E equal to sigma into T power 4 minus T naught power 4. Then if the body and the enclosure are not perfect black bodies, then that will have the relative emissivity epsilon. Then how will be the equation? E is equal to epsilon sigma into T power 4 minus T naught power 4. This is about the Stephen Boltzmann law. Now, based on these concepts, we are going to do some problems. Let us see one by one. Now, the two rods, in the first question they are given two rods, one of aluminium and other is the made of steel. So, having the initial length as L1 and L2 are connected together to form a single rod of length L1 plus L2. Now, the coefficient of the linear expansion of aluminium and steel will be alpha A and alpha S. Alpha A is for a linear expansion of aluminium and alpha S is the linear expansion of the steel. And if the length of each rod increased by the same amount when their temperature are raised by T degree Celsius, then the ratio L1 divided by L1 plus L2 will be. So, we have to find if the length of both the rods is increased in the same amount, means when the temperature, what will be the temperature rise of, that is they have given as T degree Celsius and they have given the ratio of L1, the length L1 divided by L1 plus L2. So, let us find.